afternoon, everybody. Now I'm going to show you a demo of how easy we can build a data center using Juniper Apstra. So in my data center, I have two pair of switches that are going to form the EVPN-VXLAN, and I know that EVPN-VXLAN usually using a spine and leaf topology, but in this case, yeah, it is possible if we want to create using a collapsed fabric like this. So I only have two pair of switch interconnect between each other, and then I have three servers that are needs to communicate between each other, and also they also need to communicate externally through the internet. This is the typical small data center that exists out there. So now I'm going to show you a demo how easy it is. So let's get started. First, what we need to do in order to create the object in Juniper Apstra, I know you might think that creating object and all of that it is the same thing like the other vendor did it, which is the way they abstract their object. It's not too easy to understand, but in this case using Juniper Apstra it is very straightforward if you want to create some objects. So first what we need to create is the IP pools, ESN pools, and VNI pool that we are going to create, going to assign to our data center or our blueprints later. And then we're going to create the logical device, what is the speed, and what is the device profiles, and what is the port roles and all of that. And then we are going to create the rack template, and then finally we're going to apply those things into our blueprints or our new data center. So I have two data center being pre-built now, data center 1 and data center 3, but we can ignore it for now. What I'm going to do later, I'm going to create a new blueprint so you guys can see how easy it is to build a new data center. Okay, first what we need to create is the pools. So I actually have already configured that, but to see how we can automate that using a Postman, so you can download this collection in Juniper Apstra API that is available in the internet. You can just download it, you can clone it if you want to, and then you can apply it and modify it and all of that. But in this case, first what I'm going to do is I'm going to authenticate myself first. So I'm going to click send right here. Now you need to put your authentication first here in the body, and then you copy this authentication token into your collection over here. Okay, and then you hit save, Control S, or you can click the button over here. And then after that, for this one, the authorization is inherited from the authorization from parent, inherit the auth from parent, so it will be used what we have put in here, the auth token. So I'm going to just run the folder, and then select the file, and config. I know it might fail because I already have those objects in my configuration, but I'm going to just show you how easy it is. See, it's unprocessable entity because I already configured those using this method as well. Now I'm going to show you the document that I'm using. Where do I store that? Okay, on the folder, select it, the API data. So yeah, something like that. The API data, there you go. This is the data basically that I have. This is the ASN name that will be assigned, and then comma the first ASN, the last ASN. You can have as much as you want. It will go for the iteration, each iteration, and then run it. As you can see here, I have 5 iteration, but when I click into the Postman, see the iteration is changed from 1 to 5. Then I run it, yeah, something like that. And the same thing goes with to VNI pool, IPv4 and IPv6 is the same thing. Okay, I've created all of that object, and then when we have a look at the resources, yes, and pool, as you can see, this is the one that we have created in the Postman runner. Okay, for the ASN DC2 we haven't used it, so that's first thing that we have to do, create the resource, and then we can start see our devices. I have pre-onboard my devices using ZTP. So basically you just run your DSCP from this ZTP, and then the ZTP will give an option to each device to recognize the Juniper Apstra IP address, and then it will be self-registered. It's pretty straightforward. Yeah. Okay, and then I'm going to go to device profile. I'm going to create a new device profile. Sorry, I'm just going to copy it because I'm too lazy to do all the thing. Yep, there you go. You can just clone it and then change the ports, because I only have 10 ports because it is virtual ports, you know, and then check if the conversion is the same. As you can see, the port 1 will be converted to GE000 and something like that. The interface map, we still haven't created that, so basically you just can clone and change the port setting if you are using a virtual device like I do, but already created here. The device profile VJuno switch. I'm using the same method to create this, and also we can, after creating a device profile, we can click on logical device and create that, change it to 10, something like this, and then the number of ports, the speed, and we can create a port group, something like that, and then we can hit create. But I already have that. LD VJuno switch over here, yeah. And then for the interface map, it just kind of sorry, for the interface map, if we want to edit it, it's just the association between logical device and device profile. So you need to select your previously created logical device and device profile. It's basically kind of tying it up and see what is the speed. It's pretty straightforward. If you want to see here, just click one by one for each port, and then you click create. So since I have created that, so I'm going to go to the next step, which is creating the rack types. I haven't created this, so I'm going to create it in the builder, because RT for rack type and L3 collapse, L3 collapse rack type using the switch and no access switch. Okay, because as you can see in my diagram, I don't have any access switch, but if you have that, you can just configure it as you want. LD vision switch, I'm going to name it leaf. Links per spine, we don't have spine, sorry, I forgot to check the L3 collapse. Leaf, the logical device. LD vision switch, the one that we have previously created, and we want to create a redundancy protocol for ESI. There you go, there we have it. If you want to add some new access switch, something like that, you can just click it over here. Or generic system if you have server, but we'll do it later in the blueprint creation phase. Okay, I'm going to create it. Sorry. Yep, I'll delete it. Okay, because the one I forgot to delete that. I've pre-configured that before this video is being recorded. Okay, I'm going to create the template. GMP data center 02. This is collapse fabric. I'm going to select the rack type. How many mesh link count? Just for the redundancy purpose, I'm going to use 2, and the link speed is 1. Okay, there you go, there we have it. And then what we're going to do, we're going to create the admin configuration if we want to SSH to the device. So basically just put some Junos config over here. Okay, then blueprint, I'm going to create a new one. Data center 2. Okay, and data center is there is 2 reference design here. Just the data center if you want to use a template, or if you want to use freeform, which is you're the one who dictate how the switches interconnect between each other, but we're not going to do that. We're just going to create a data center, because if you have some in common topology, you can just use freeform. You know, it is how flexible it is to configure using Juniper Apstra. And then you create the template. There you go, you don't have to do anything, it's being associated. This is the association logical structure, and then click create. Okay, going to wait a moment until the blueprint is created. Okay, as you can see here, there is a build error because we haven't put any parameters to be configured on the blueprints. So first we need to create the ASN for the leaves. Okay, don't have that, click that, and then for the loopback IP, we're going to select that, leaf to loopback, and then that is the one that I've previously created on this resources pool. Okay, then we select fabric link. And then we can assign, we just follow the error button and then start filling the things up until it's complete. So yeah, it's pretty easy. We can select that, click that, and assign the selected interface map. update it, and finally we don't have any error, but here it shows warning because we haven't assigned the intended switch that we are going to use. We select deploy and update the assignment. There you go. Our data center is being built. That's how easy that is. But I want to change the host name. DC2 switch 1, DC2 switch 1. Okay, I need to change another one. DC2 switch 2, and final step, DC2 switch 2. There you go. There we have it. Okay, now as you can see here, we have the uncommitted change, but before that, yeah, I'm just going to hit commit to see the rendered config. Okay, let's see. Let's wait. Yeah, there you go. This is all the configuration that we have put. They will configure it automatically. As you can see, the neighbors and all of that, it's based on the parameters that we have put previously. Okay, and we click commit. First data center build. Okay, there you go. While waiting for that, I'm going to show you that I have one firewall over here that is doing a source NAT. I've pre-configured this firewall, so it is basically doing a source NAT from the LAN or untrust interface to the from the trust interface to the untrust interface. This is how it looks like, and make sure if this firewall have the access to the internet, and it does. It did. Okay, there you go. Now I'm going to create a new routing zone. This is basically the VRF production, something like that, and then that's it. Yeah, as you can see, show me an error. We can just click it. That's how easy that is, because it shows me if something is missing. Okay, I'm going to create 3 subnets. Okay, I'm going to create 3 subnets that I'm going to assign it to each server over here. Okay, VN, because it stands for virtual network. Web, I'm going to use VLAN 21 182 168 21.0 21.1, and then don't forget to create a connectivity template. This connectivity template is basically like a template that we are going to apply to each port that we are going to create later. Click that, tag and untag, and also assign to those pair of leaves, so it will be visible when we are trying to configure the ports later. Okay, create another one. VN app. Click that. I'm going to create a VN vMotion. And later in another video probably I will show you how we can stretch the subnets between data center using L2 EVPN-VXLAN, L2 EVPN, yeah. VLAN 10, Okay, that's easy. And also, yeah, I forgot to change this because later I'm going to use it for this threads VLAN. Okay, now I'm going to assign the virtual network identifier that we have created, or VNI. Select DC2 and routing zone, leave loopback, and just assign DC VRF DC2 VRF loopback, update. That's it. We have configured our interface VLAN. Then what we are going to do is to create a connection, the external connection to the server. The generic type is basically when you are connected to another device like firewall, routers, or L3 out connection device. You can create it, select the generic type external, but if you want to use those interface to be connected to the internal devices like server, your access switches, and all of that, you can use the internal, as you can see here. Yep, so I'm going to connect to my server 7. Select because it is 1 times 1 gigabit, so I'm going to give it a tag web. Next, then I'm going to select my interface, server 7, server 7. Okay, port 4. It is connected to 4 GE004, this one. Okay, and then I'm going to give it a tag web. Create it. I'm going to create a LAG to another KVM05 app. Next, oh sorry, I need to check that. KVM5. Sometimes we forgot, yeah. It is connected to port 5 DC1. Yeah, there you go. Add the link, create LAG, active, the link tag is app. There you go. Click create, and then another connection is port 6, believe it, yeah. KVM06, click that, and I'm going to name it vMotion because it will be stretched later. Okay, add link, create LAG, HTTP active, stretch, going to click create. Okay, and now I'm going to create a manage the connectivity template to assign those ports into a VLAN. VN app, vMotion, web. The easier part is the previously we have assigned some tags here, so we know that where to assign to. Server 7, we will be using web, this is app, and this is vMotion, and then we click assign. There you go. Now let's see if we can successfully let me check first. Take some times. Okay, yep, here you go. Then click commit. Configure VN and routing zone. Commit. Okay, there you go. There we have it. Now from server 1, I'm going to ping my gateway. My gateway is always .1. Yep, we can ping it. Can we ping to another device? 22 dot excuse me, 101. Yeah, we can. Can we ping to another device? 10.101. Oh, I forgot. APA. There you go. There we have it. We can ping everything. Ping 808. We haven't yet able to give the internet access to the server. Now what I'm going to do is I'm going to create a static route, and it is pretty straightforward, you know. Click connectivity template, add a template, and then click primitive. I'm going to have the IP link, and then static routes. That's it. Then click parameters, X internet access via FW, and we select the routing zone, production. The VLAN ID I'm going to use uncheck, the IPv4 numbered or none because we are going to assign it later. The network is basically a default route. Okay, a shared endpoint if you want to use it, because in this case, if the next hop is shared across multiple remote systems, so if you have one you know, some core switches, the external device that or the external device that are going to have the same next hop, you're going to check that. But if the next hop is different, then we're going to ignore it, because in this case I'm going to use the 2 interface. As you can see, it is using a different IP, so the next hop is not shared. I'll click create. Okay, now we're going to assign those a link. I believe it's port 7. Port 7. Yeah, GE07. You can ignore that because it's I'm looking at my internal automation to create all of these VMs, so you can just ignore that. FW02. The internet. Next, spot 7 link, and we are not going to form the LAG here. Oh, sorry, did I click external? Oh yeah, external. Sorry, almost forgot. Internet. I don't know why I can't hit enter there, but yeah, there you go. Click next. Yep, there you go. Yep, we're not going to create LAG link aggregation. We're not going to do that, so yeah. Okay, after assigning this template, our topology is going to look like this. It's the same like what I have shown you here in my draw. Okay, then we can assign it over here, and we also can assign it here. Manage connectivity template, internet access VFW. As you can see, the tag internet, check that, assign. There you go. Then we can follow the error. As you can see, but I don't like it to change it over here because I kind of like to change it on the routing zone. So click the routing zone, production, show you the red. It's basically asking you if you have a pool for that, but I don't create any pool for that because I want to do it statically. So click this, change it. For switch 1, I'm going to have the IP address of 102.2/30.6/30. Too easy. Copy it. .1.5. Then it will automatically create. This is basically the neighbors. So yeah, I forgot to tell you that. This is the neighbor where you are going to point your static route to. As you can see, the static route will be automatically configured. See how easy that is. And that's it. Check all device. Yep, there you go. Then we click commit. External connectivity to internet, commit. There you go. Okay, now we get our ping working to the internet, and let's try to do this. Or call min v https. Yep, there you go. There we have it. You can access the internet. See how it is, how easy it is to build your data center using Juniper Apstra. It only takes a few minutes and then you're done. And it will be so much easier if you have your automation in place, like Terraform, or using Postman, using to create each object, and it will be so much easier if you can do and plan all of that things. Okay, thank you for watching. Bye bye.